Assalamualaikum warahmatullahi wabarakatuh, and good day to all students. Today you are going to learn about odd and even functions. Okay, yesterday you have plotted few functions, right? Then what are you going to learn today is how can you determine whether the function is either an odd function or an even function, or neither even nor odd functions. Alright. So we're going to start with properties of even and odd function. Let ft be a real valued function of a real variable. Okay, therefore, the function is an even function if f minus t equals to ft. What does it mean? If you substitute t by minus t, then it is equals to the original function. Okay, and the second property is the graph of an even function is symmetric about the y-axis. I would say that the simplest example of an even function is an even power of t. For example, ft equals to t squared, ft equals to t to the power 4, and as well as a cosine function, right? So these functions are the simplest example of an even function, right? So how can we determine the function is an odd function? It has properties of f minus t equals to minus ft. Means that when you substitute the t by minus t, the resulting of f minus t is equals to minus ft. Okay, the second property says that the graph of an odd function is symmetric about the origin. Okay, few examples of an odd function. We have an odd power of t. For example, t to the power of 1, t to the power of cube, alright, and a trigonometric sine function. Alright, example 4.3. First example, we have ft equals to t squared. Okay, it's an even function, as I said just now. The power of the even power of t. Look at the property. The first property, f minus t equals to, then we're going to replace t by minus t in bracket squared. So this is equals to t squared. So you can say that f minus t equals to ft. Then we're going to plot the function. Alright, so this is how you plot the function. Ft equals to t squared. So you can see that second property, the graph is symmetric about the y-axis. So this is y-axis, the green color. Alright, okay, means when we fold the function, okay, by this axis, it's going to map onto each other. Alright, okay, so the function ft equals to t squared is an even function. Look at the second example. We have ft equals to t cubed. Right, first property, when we substitute the t by minus t, so we're going to put minus t into the function. So minus t bracket cube. So this is equals to minus t cube. Alright, so you can say that f minus t equals to minus ft. Alright, second property, when we plot the function, so this is how t cube looks like. Alright, and you can see that the graph is symmetric about the origin. Okay, therefore we can say that ft equals to t cube is an odd function. Okay, I list down few examples of even and odd functions. So we can see that even function, the examples are absolute t, okay, t squared, t to the power 4, t to the power of 6, the even power of t, cos t, cos hyperbolic t, and these functions have property of f minus t equals to ft, and as well as it is symmetric about the y-axis. Okay, so these are the list of examples of odd functions. We have t cubed, t to the power of 5, an odd power of t, cos hyperbolic t. Okay, these functions have properties of f minus t equals to minus ft, and is symmetry about the origin. Okay, example 4.5, if you are given a piecewise function, ft equals to 1 plus t, okay, from the interval minus 1 to 0, ft equals to 1 minus t in between 0 and 1, is a periodic function because you have this statement, okay, the fundamental period t is equals to 2, so which means that as t increases or decreases by 2, the graph will repeat itself. Okay, so you can say that this function is a periodic function. Okay, the first question is sketch the function over the interval -3 to 3. The second question, determine whether the function is an odd function or an even function or neither odd nor even function. Alright, so this is how you sketch the function, the periodic function of the function ft. Okay, you learned this in the previous topic. Okay, and t, the fundamental period, is equals to 2. Alright, so you can see that based on the plot, the function is symmetric about the y-axis. Okay, and when we test the first property f minus t, we substitute t by minus t, we can see that, okay, we're gonna get it is equals to ft. Symmetric about y-axis, f minus t equals to ft, therefore the function is an even function. Okay, so these are few questions that you can try to test whether you understand how to determine whether a function is an even function or an odd function or neither both of them. Alright, okay, so you just need to for question number 2, you just need to test whether it obeys the first property, f minus t equals to ft or f minus t equals to minus ft. If the function doesn't have the properties of an odd function or an even function, we're going to call the function is a neither odd nor even function. Alright, thank you for listening. I hope you enjoyed the video.